Hi, my name is Ken Masterson. I wrote the Microbiome prescription website, and today I want to explain a little bit about a new experimental feature, which is actually saying, okay, what food should I be consuming to adjust my microbiome? So I call it simply experimental food suggestion. Experimental is important to emphasize because that's what it is. It's an experiment. Now, as a starting point, let's do an overview. First step we do is we collect nutrients for food. Variety of studies and sites have this information available. We now get a list of nutrients. 700 plus different nutrients are recorded in a variety of databases. We have our joyous database of studies showing how different substances modify the microbiome. 2,400 there. They are not exact matches, unfortunately. So what we have to do is the second step. We have to match, map, or triangulate nutrients to modifiers, so that if something shows up as things like pasta, well, we don't have pasta. We don't have studies on pasta's modification of the food. We do have studies on high carbohydrates, high starch diets. Pasta could fall into that classification. So we could say, okay, let's take a high carbohydrate diet. Let's take a high starch diet and put the two of them together as a triangulation of what pasta will be doing. The first step is we go and we aggregate all of these stuff together to see the possible impact on the microbiome. So let's go on to the next step. First, current sources. We have 6 different sources at the moment, and as I find and download and merge in additional sources, there'll be more. You can see there's a variety of there, which means we have a variety of foods, including, for example, from the US sources, Eskimo foods like Eskimo ice cream, or variety of whale meats, which are unlikely to ever be used for most people of the site, but it is there. And if you happen to be a native in Alaska, guess what? We can tell you which foods native to you should be doing. Okay, so we collect all the information we can from as many sources as we can, put them all into a database, and this will hopefully be growing as time goes on. Here is a simple example. Agnetuck, which is fish or berry with seal oil. It's a Eskimo ice cream. Lovely. And first thing you need to be aware is different sources of nutrients in food measure different things. Sometimes they use different names. Sometimes I can match up the names. Sometimes I'm not able to. Amount will vary by the source. If you take a look at pasta, which is made in the US versus pasta made in Italy, you actually find there will be differences in nutrient contents. Minor differences, but still will be there. So here we have it, and here we see what the nutrients, and you notice there's a little star here. That means that the amount of this item, total fat in this substance, is more than the typical amount in most foods that have fat in it. So it's marked as significant. So it's a factor to consider for this food. And considering using seal oil, it's not greatly surprising. And then we could have the breakdown by themselves of the 3 different types of things. None of them are that much, but all of them together goes into the high levels. So we now know that for estimating it, it's basically going to be very close to having a high fat diet. Okay, let's go on. The next thing we have to do is avoid slipping into a homeopathic approach. And by that I mean, because X increases some bacteria, Y in study, we cannot assume a trace amount will cause that. In fact, if you go back to the studies, you find that most studies are based on higher than typical levels of the substance. So the result is we go and we look at all the nutrients, and we basically ignore the nutrients if they are typical amounts for our food containing them. And we only deem the nutrients in the food to be significant when the amount is higher than typical levels for food that contains it. Now, how much higher is subjective, and that is probably going to be subjected to tuning as we work with the site. We also triangulate for missing data. For example, we have 774 different nutrients at the moment. That may well go over 1,000. We have 1,962 different modifiers from studies. In some cases, we have identical matches. Phenol and phenol. Voila, we have a match. Nice and easy. We have nothing more to worry about. Now we hit a different substance, and it is, what? We don't have it. So what we do is we look for foods that have a high amount of same substance to it and see if we find that in our modifiers. If we do, we take the ones which are the high levels, maybe 1, maybe 2, 3, or 4, or even more, and then we take all of those and say, okay, take all of those things, shove them together, aggregate them, and we use that as a proxy, as a synthetic modifier. Simple as that. It's the best we can do with the knowledge that we have available. Now, when we go and actually do suggestions, we have what I love to always do is have traceability. So the result is, why is the food selected? You go and you look at the suggestion list, and you have a list of food. You click on one of the foods, and you go over, and then you'll see what's in the food. And what's in the food is starred with things which are higher than typical amounts. So one or more of these items is the reason for selection. The reason may be that lactose improves the microbiome, and none of the other stuff has significant impact. That's fine, but at least you know what the substance is, or which could be causing it to be picked was there. The actual details, that's a bit messier. Last and very important factor to keep in mind: portion size is not considered. Whether if you're taking a fennel capsule or a piece of meat, the size of it doesn't come into it. And actually, for the content, since it's per 100 gram, that does come into it. But again, we are trying to work with a complex situation, basically cooking, diet, a combination, making some simplifying assumptions which are reasonable, and hoping we get reasonably good keyword experimental results. Okay, so experimental. Data mapping is subject to division. So is based on multiple studies of food contents. So we have solid science there. It is based on multiple studies that have some substances impacts on the microbiome. Solid data there. What we don't have is not based on significant number of studies of foods on the microbiome. We are logically modeling. Results will vary, whether or not they work or not, depends on how well we do the mapping. And some cases the mapping may be invalid, it just doesn't work. We just don't have the information, and what we are able to infer falls down. Okay, let's go over and take a look at actually doing it. So when you log in, you will go to the change your microbiome sample. For example, here I have let's go down here. Okay, let's take this one, and you go down, you have the things, and you find you have a new checkbox here, which is show food suggestion experimental. I'm going to use Keltoff multiple ranges, and I just go to click here. Give it a few seconds, it got some work to do. And it comes out and shows the food suggestions. And it shows, in this case, shows 1,300. Some cases would be 100 or 200. Some cases would be more. And what it basically does is calculates all 2,500 or it says 4,000, I forget the exact number, food substances, and then takes the top number and takes the bottom numbers and shows that. So those which are in the middle are excluded because they are typical foods. So we see things like walnut, ravioli, okay, etc. So if I go down to any of these, like walnut, I see the reason it is. If I click here, I see it's because there are two particular things in the walnut which one of those two was the reason it was selected. If I click on this one, I'll see Japanese walnut there. So only two things have that: walnut, let's try look at everyone, and walnut, fennel, mulberry. So going back to the original list of suggestions there, that I can pretty much infer which substance it was that is being picked, and then we go down and we look at other things. Some nice things there, and let's go and hop to the end, and lo and behold, for the end we see things like cowpeas. Notice that we have two things which are almost the same, which are there, and the reason is we have two names is because it's in two different databases. If you go and look at each one, you will see that there is differences between the two of them. In one, water is described, in every one it's called moisture. Again, everything keeps to what the original sources named it. There we have aspartic acid there, over here, and we have aspartic acid. So we have some things in common in terms of names, and other things we will have differences to it. So that will hopefully give you some background as to why sometimes things show up twice. Different names, sometimes different measurements. Okay, so that is basically it. Just go and do it. There's no consensus feature lit. There is not much else. However, if you go back here, and actually, let's see, if I remember right, we should have the manual entry stuff working too. So coming soon, very soon, is custom lab suggestions. We'll have a checkbox underneath here, which is on the other screens, and I'll get that added, and you can now go and do the same thing with your modified suggestions. So that's basically it.